This is web performance in 2019. We're going to talk about a lot of different things. We're going to talk about why make web pages fast. What does fast even mean? And we're going to do a quick rundown on how browsers work, how to measure performance, and tips and tricks to optimize each stage that the browsers are rendering your page. So this is me. It's my daughter Millie. We went to the dentist earlier today. It's my dog Dexter. We do have another dog named Coco, but don't love her quite as much. I'm just kidding. So I work for a company called Lullaby. Lullaby is a design development strategy company. We're 100% remote. So we have maybe 60-odd employees all throughout the US, Canada, and Europe. And we work on a lot of big websites that tend to revolve around Drupal or include Drupal somewhere in the stack. We've done websites like msnbc.com, the Grammys. I've worked on SpaceX, the Sci-Fi Network's website, and a lot of other cool and some more mundane things. So let's talk about maybe some speed. Like why, when people hear performance and website performance, they immediately start thinking of like database queries, function calls, and things like that. But we're missing out on the front end performance. And so I'm going to throw a couple of stats, and I could do these stats all hour, but we don't have time for that. So 53% of all mobile site visits are abandoned if the page takes longer than 3 seconds to load. I think this is me because I'm super impatient. Mobile sites that load in 5 seconds earn twice as more ad revenue. That totally makes sense. Something to keep in mind is when I talk about like I mentioned earlier, like database queries and function calls and stacks and everything like that, but 80 to 90% of the end user response time is spent on the front end. And this is the time it takes that the browser is rendering the website, executing the JavaScript, and actually putting stuff on screen. So that's where to start. So to kind of illustrate this, I want to show this is a website for a conference I went to not too long ago, and the time to first byte on this was maybe in the neighborhood of like 20 to 30 milliseconds, but the website didn't render till about a second and a half. So we have like over 90% of the time is spent on the front end. This website could render probably in a half second or less if the front end was a little bit quicker. But when I talk about making a website fast, like, what does this mean? And so when I say this, you have to look at this animation because I spent so much time on it. There it goes. So let's talk about performance metrics. I'm going to talk about a couple different things, including time to first byte, time to first meaningful paint, time to first interactive, and speed index. You're going to hear all these terms. I'm gonna kind of dissect each one of these for you initially. So let's talk about time to first byte first. It's pretty easy to understand this. It's from when you start your navigation to where you actually get your first byte back from the website. Delays here kind of indicate a backend problem. Effective caching really helps. So something that helps out is like content delivery networks. Content delivery networks are basically a service that you pay for, and it literally stages your HTML and assets from your website at data centers that are closer to you physically. And that's really positive because the speed of light can only go so fast. And yeah, I guess I already talked about CDNs. When you're looking in Chrome Developer Tools and you run a performance profile, which we'll get to a little bit later, you're going to see the time to first byte right in the beginning where that little arrow is, and that's the data coming in. So you can see the time to first byte on this one is, what is that? Looks like around 800 milliseconds, something like that. The next metric is time to first meaningful paint, and that's when your primary content is actually visible. It marks the paint event that follows the most significant change to the layout, which is kind of ambiguous. So when you're doing a performance profile, you can select the options, select an option to capture screenshots, and that will show you what the website looks like at any given point in your performance profile. And so on this particular website right here, you can see that the website actually rendered earlier, but the text didn't come in until a little bit later because it was probably waiting on a font. But when that text came in, that's the first meaningful paint because that's what's important for the user. Time to interactive is when the load is finished and the main thread work is done and the website is consistently interactive. So have you ever gone to like a website, especially on your mobile phone, and you can see everything and you start like tapping and it's not doing anything. You start tapping harder, which it doesn't like really help anything, but makes you feel better. Like that's the website not being interactive. The time to interactive is a little bit more ambiguous than that because technically you can have your JavaScript executing and do this, but that's the easiest way to think about it. Something that takes into account everything is speed index. So speed index takes into account how quickly the page is rendered, which takes into account the time to first byte and everything else. But something else that's kind of new for this is how quickly the web page approaches visually complete. And so you can see an example in this right here on like the top row. You can see the website, both websites might finish at the exact same time, but the top row approaches that a little bit quicker. And so that will have a quicker speed index. And you can get your speed index by running an audit within Chrome Developer Tools, and I'll be walking through that in a little bit. We're all good, right? I see a lot of nods. Yeah. Let's talk about how browsers work. You type in something and you go to it and it starts doing stuff. What does that mean? The first thing your browser will do is it starts downloading the file that it's getting from the server. As it's actually downloading this file, it starts parsing it. It starts looking in this file during the download because it wants to be super quick. Each browser wants to be super quick, and so they have a lot of different optimizations. It starts prioritizing the critical content. Critical content is stuff that actually blocks your rendering of your website. Have you ever, you go to a normal website and you see the website pop up, and then after that you see the images pop up. That's kind of a normal thing. The reason that the images pop in after is because they're not critical. So you don't need the images. The images are not critical content. So the browsers will prioritize this, so they'll prioritize your highest. Your highest is the initial document, which of course you can't do anything without that. Your CSS is your style sheet. And in order to look right, it needs to download that style sheet. You also have, as a high priority, you have web fonts, which is a web font, and scripts tags that end up that are in the head of your document, and any type of like asynchronous or like XML, HTTP requests. Those are all high priority. Medium includes scripts tags that might be in the footer or outside the head, and you have low that is like images. Something else that's low is like style sheets that is marked as like outside your media query. For example, like print style sheets. It will download those last. You can actually see the priority within Chrome Developer Tools. Yeah, you can see like there's a little priority column there. It's not visible by default, but if you right click, you can select priority. So it downloads everything. It starts downloading these assets, and then it has to start looking at the style sheets, and it has to start looking at the JavaScript, right? So it's going to parse and execute the JavaScript, and it's going to completely do that in the head if it doesn't have an async attribute or a deferred attribute. And as it's rendering, it will either async or afterwards do the JavaScript that's in the footer, and it generates. Once it downloads the CSS file, it will generate the CSS object model, and the CSS object model is basically kind of a big object, and starting with the body, and you can kind of see how the like the styles will cascade down into the lower styles. You'll have like your body has, in this example, font size 16 pixels, and that will cascade down to the paragraph tags and spans and everything else. At the same time, it's generating the CSS object model. It generates the DOM, which is a document object model, and that's a very similar approach. It's a big object that contains all your HTML and anything else that your JavaScript inserted, and it'll also include any type of like pseudo elements that your CSS put in. Well, I'm jumping ahead a little bit. The render tree will create the CSS, or will create the pseudo elements. Your DOM and your CSS object model get combined to generate the render tree. The render tree is the render tree will not have in it things that are displayed none. It will have pseudo elements and things like that. And then once the render tree is created, the browser will know how to do the next step, which is called layout. So all of this all together, of course, happens in like very, very quickly, which is really, really fun to think about. The next step is layout. If you go to a lot of Mozilla Firefox documentation, they call it reflow, but it's basically the same thing. And it's basically calculating how much space an element needs on a page, and there's a lot that goes into that. How many letters are in the text, the font, the CSS rules, overflows, all that type of stuff. It has to calculate where to place them in relation to the other elements in the viewport, and it's a very expensive operation. When you're doing layouts, it uses a whole bunch of CPU power. And in a perfect world, you want to do your layout just one time as your browser is initially rendering the site. This is an example off of YouTube of an early version of Gecko, which is what Mozilla Firefox is based on, doing layout. And it's a good illustration of what the browser has to go through in order to make the website, and how it's kind of complicated. After you have all the space partitioned out, it does what's called painting. And painting is basically the process of filling in the pixels, including the text, your colors, your images, your borders, any type of like background image, and anything like that. It's also a very expensive operation, and you don't want to paint more than necessary. But when you're doing your painting, you can have kind of multiple layers, and I like to visualize them as maybe Photoshop layers. You know how if you have multiple Photoshop layers, you can kind of like move one around in front of the other and stuff like that, and it's pretty easy to do. The browser does a very similar thing where it will create layouts, and it's very easy to move things around, and that step is called compositing. So the final step before you see something on your page is where the browser takes all the multiple layers that it created, and it just writes them to the page, writes them to your screen. Compositing is a very cheap operation because it uses your computer's GPU as opposed to CPU. And so that's kind of nice. When you're doing animations, I'm going to talk a little bit about this coming up. When you're doing animations, you want to structure your code so you're doing more compositing, less painting, and less layout. There's a lot of things you can do in JavaScript that will cause your website to do multiple paints and multiple layouts and things like that. So we know a lot now. We know how the browsers work. We know that they download, that they make these big objects, that they merge the objects, that they do all these layouts, that they do paints, that they do compositing. It's a heck of a lot of work. And now we're going to measure it. So this is, I don't know if you noticed earlier, the illustration I had was this SR-71 Blackbird, which is like the fastest jet ever. And so I've been taking like little illustrations of it and marking it up with various different web component terminology, which of course doesn't make sense. But I like this one because you can see how it's labeled as V8 engine. The JavaScript engine within Chromium is called V8. So I thought, hey, that's kind of neat. Anyway, let's do some demos. And so I am going to escape out of this, Command F1, and I'm going to open up Chrome, and hopefully everything is just keeping track. So the first thing that you typically want to do when you're profiling something is you want to open up a guest window. And the reason why I open up a guest window is because it doesn't load any type of browser add-ins and plugins. When you might have things like ad blockers that, of course, will definitely affect the execution of your JavaScript and everything. But even if it's something like LastPass, which I use, it will still parse your DOM and look for things that it's supposed to be doing, and that will affect your performance. Browser plugins slow down your website, so we don't want to track that right now. So let's pick out a website here. So one of the websites that I have picked on before is called TechCrunch. I think everybody's heard of it. And we're just going to open it up, and we are going to do some profiles. So who here has used Chrome Developer Tools before? Awesome. So we have a couple hands up, a couple hands down, and everybody's going to learn something. So in order to use Chrome Developer Tools, you right-click on the browser, and you go to Inspect. There's a couple different ways to open it, but that's how we're going to do it. And so Chrome Developer Tools has a couple different cool things in here. So the first thing that we're going to show is the audits. And by default, it's going to be set to mobile and 3G. For purposes of this demonstration, we're going to do desktop and no throttling. But when you're doing real performance profiling, you do want to take into account mobile users that are on a slow network, that might be trapped in a building with a tin roof and getting 3G, even though they're in the middle of Gainesville, or users that don't have, the latest iPhone or the latest fast Android phone. So I'm going to select those options. I'm going to select the option for performance. I'm just going to hit Run Audit. And what it's going to do is it is going to reload the page in the background, and it's going to run this. And it's probably going to take about 30 seconds. So I'm going to take a drink of water, and we're just going to let this go. If I was smart, I would have had like the Jeopardy music happening in the background or something like that. I think I should make myself a note for next time. So Chrome Developer Tools has a lot of really cool things in it. It gives you a bunch of really cool statistics at the top when you're doing these profiles. It gives you a grade, which is kind of ambiguous, and the grade honestly changes depending on maybe sunspots or the gravitational pull of Jupiter in relation to Mercury or something like that. But you can get a good general idea. So we're going to look right here. We're going to see our first contentful paint is pretty good. That's under half a second. Speed index is 3.2 seconds. That's kind of weird. What's really hurting us here is our time to interactive, which is 12 seconds. I'm going to hit this View Trace button right here, and it's going to show us a lot more information. And we can actually dig down pretty good. So let's expand the network and go into frames. So you're going to see, like right here, it'll actually show the screenshot, but that's not what the main thread is what I'm looking for. So can everybody see that a little bit better? Cool. So the first thing that we're going to see right here is our time to interactive is really, really short. So let's I'm going to go to the elements or the network tab, and I'm going to actually look at that a little bit closer. I'm going to go to timing tab up here. So our time to first byte is 14 milliseconds, which is ridiculously quick. So it's a pretty popular website. I'm guessing that they use a content delivery network. And you can actually get like some information sometimes on by looking at the headers to see like even what their CDN is and stuff like that. You can see stuff like the server and things like that. The next thing we're going to look for is first contentful paint. Let's get out of here. So something new that Chrome Developer Tools does is it actually marks these. So first contentful paint is right here at about a half a second. So that's looking pretty good at this point. You have your DOM content loaded event, first meaningful paint, and way up here in the red is where you're going to see the load event. So the load event is the document load event is after everything's loaded. So if you were to look at all this type of stuff, it's all going to be ads. And, there's ads, there's trackers. I'm pretty sure there's probably like some pixels from the NSA in here and several other things. But that's kind of an overview on how to look at this. We're going to look a little bit closer, and we're also going to look at some third-party scripts in a little bit too. But right now, I just want to move on. So let's talk about how to start optimizing this stuff. So if you remember, the first thing that the browser does is it starts downloading stuff, right? That's pretty important. So the first thing to do is use less bandwidth. That almost comes without saying, but it's still important to say. Limit the use of large images. I have seen many websites that will upload, a 5 megabyte background image that's not quite important to the content. You can really understand and get the content without this, but it still uses up a lot of bandwidth and kind of slows everything down. HTML now supports responsive images. Responsive images are the use of the picture HTML element or source set attributes within the image HTML element. And these are super cool because if I'm on my phone, I don't want like a large background image. I just want a small background image, or I want a lightweight background image or something like that. Responsive images basically just look at the viewport and say, all right, well, this is a smaller screen, so I'm going to download a smaller image. You want to limit your network requests. Every time you browse, traditionally, when browsers are using HTTP1, and we'll talk about the difference between HTTP1 and HTTP2 and what that means, but traditionally, they have to reach up to the server for every asset it downloads, and it has to do what's called a TCP handshake, which is basically like, hey, 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 for every single asset that's up there. And all this, not only does it take bandwidth, but it takes latency, and that takes a lot of time. HTTP2, which is a newish protocol, handles that a lot differently and a lot more elegantly, where it only does the TCP handshake once, and then it can send down multiple assets over the same stream, which is kind of neat. And so what am I looking at right here? So I'm looking at, sometimes I don't even know. We're looking at large images here. So you can see, we're looking at we're looking at the network tab, and you can kind of see that there's some large images and fonts, and I'm not even sure what I'm going for on that slide. I should probably mark that. Moving on to the purple pattern. Purple pattern is a newish kind of, what am I calling it? Like a newish strategy to render the website really quickly. And it's kind of being championed by Google, who I think actually coined the term. And it stands for push, render, precache, and lazy load. At its core, it is just a strategy to immediately send down the critical assets, render that, and then any other links that are in the pages, download the index files for those. So if I'm on a big website and I see a bunch of links, it'll actually download those in the background, just the initial document. And then when I click on those, it'll be cached either in Service Worker or the browser cache or something like that, and so it'll load instantaneously. And it's a really, really nice user experience when you click around and your website just loads like that. So let's kind of look at this right here. Having some technical difficulties here. This should be showing some. This should be showing some network downloads here. Well, all right. So this is a website that I've worked on several years ago, the Sci-Fi Network, and I like to pick on it because if you go to it, the assets from the origin domain are, I don't know, a neighborhood of like 50, 60 assets or something like that. But if you look at this right at the bottom, you're going to see 356. And each one of those is like the TCP connections happening and things like that. And this is kind of like maybe a case study in your website being slowed down. A lot of people tend to use ad blockers to kind of block these types of things. And in my opinion, it's not so much about blocking the ads, it's about like speeding up the website, you know. I want a fluid user experience, and I think most people do too, you know. And situations like this just kind of make me a little bit angry. There's a couple things that if you're a website developer and you want to make your website quicker, you can do right now. And that doesn't take a lot of effort. And one of these is resource hints. And what these are is they're basically tags that are in the head of your document. And you put them in there, and then your browser will immediately download those resources without having to parse any type of CSS files, any type of JavaScript files, or the rest of the HTML. This is really useful for things like fonts because if I'm loading a normal web font, I have like the @font face rules in my CSS, right? So in order for the browser to decide if it wants to download those files, it has to first, of course, download the document, has to look at it, see that there's a style sheet, has to download the style sheet, has to parse the style sheet. Then it compares the rules for the @font face to see if those elements actually exist on the web page. And then if they do, it looks back at the CSS and it sees, all right, the path to these font files is this, and it initiates the download of those font files. And that is a multi-step operation, which is kind of a pain in the butt. And this, if you've ever gone to a website and you see the background image or the background colors pop up before the text pops up, this is exactly what's happening. And you can fix it by using preload, link rel preload, and point it to a font file. I'm going to show you some code samples in a second. There's a couple other resource types hints. There's one called DNS prefetch that if you're downloading resources from multiple domains, it will pre-resolve your IP address for that other domain, so your browser doesn't have to do that when the time comes. But that's being a little bit depreciated by the next one, which is Preconnect. Preconnect will tell the browser to actually connect up to these separate domain and just maintain that connection for a second until it starts downloading assets. And that's super useful, especially if you're using like SSL or TLS or whatever, and it has to negotiate that security, encryption, and all that public key stuff. And that can take time. And so you can see that this is an older version of Lullabot's website here, and we had it downloading a JavaScript file, and the JavaScript file is initially rendered like into HTML, it's in the footer, but we told it to download it immediately. And if you look at this right around, I don't know if you can see it, the second item in there is that JavaScript file being downloaded. This is preconnecting to our various different APIs and domains. So it would skip the SSL negotiation. It would preconnect so it didn't have to do that SSL negotiation. So you can kind of see like a before and after right here. So before, you can see that's taken like 113 milliseconds, and it takes a little bit of time for the DNS to look up the connection and all that. So if you do that up front, you can go ahead and negate that when the time comes to make that network request. And that, a tenth of a second here, a tenth of a second there, a tenth of a second here, before you know it, you have a full second shaved off. And as we've as I've talked about earlier, the that saves money. Like that will increase your ad revenue, that will increase conversions, and more importantly, it will help ease my frustration about using the web. So altogether, this is for a website. There's a website host called Pantheon, and we worked on that earlier last year. And you can Pantheon has like really, really fast CDN, so they integrate in with Fastly CDN, and their time to first byte is like really fast. But going into this website, we were doing a project where we had to do a redesign, but we didn't have time to do like completely everything. So while the design process was going on, we did an audit of front end performance, and we implemented this stuff right here. So you can see that there's some fonts in there, and you can see below the fonts, it's actually downloading a hero image, and the hero image is being downloaded there because it was necessary. It was like the main background image to make it visually complete, and this hero image was being called through a CSS background image. So it had like the same kind of performance problem as the fonts have, where it had to the browser had to compare everything and look at the CSS. But you can see in here that I have a media attribute on the images, so it only downloads the appropriate one for the viewport size. And you can see below all of that, we're doing some pre-connects to various services, including fonts.google.com and some various different like optimizations, like A/B testing and analytics services and things like that. Something that I also want to call out on here is that when you're doing your preloads, you want to use a cross-origin attribute. There's a bug, I believe it might be in Safari, I forget exactly what browser, but it will cause, the bug causes the browser to download the asset twice because of CORS issues. If you add that cross-origin attribute on there, it completely negates it, and you can start using this today. If you look at this, it's supported by most things. It's surprisingly not supported by Firefox and is supported by Edge, which doesn't make sense, I mean, but the cool thing about it is if you use it and it doesn't work, it just doesn't work. It falls back to what you were doing before. So I want to talk a little bit about prefetching. Prefetching is is part of the purple pattern, and that's pre-connecting up to the links. Now, something that does this really good is Gatsby.js, which is a React-based static site generator. Has anyone heard of that? A couple people, or one at least. So I work with a lot of Drupal, and so there's this project called QuickLink. QuickLink is a JavaScript library that was originally created by Google Chrome Labs not too long ago, maybe like 5 months ago, and it looks at your links that are in your viewport, and when your website is idle, it will automatically start downloading these and store these in browser cache. As you scroll down the page, it'll use an API called Intersection Observer to kind of detect when links come into your page, and at that point, it starts downloading those too. And it has a lot of really, really neat stuff in there, including it checks to see if it can detect your network speed, and if so, and if it detects that you're on a slow speed, it will not download those. It does a lot of really cool things, and you can kind of see that in action. So if you're using Drupal, you can use a module called QuickLink, and if you're using WordPress, there is a QuickLink plugin. I don't know how well it is written. If you're looking at it, you can if you're looking at your network tab within Chrome Developer Tools, you can actually kind of see this happening, where you'll see your network requests come in after the idle, but then as you scroll down, you can actually see them pop in there, and it's kind of a good feeling that, hey, that's being done. And then when you click on something, it's very, very instantaneous. So this is a video of it, and I think I realized my problem earlier, where the videos are not playing on my screen, but they are playing out there. So, but now I know. All right. So network optimizations, right? You want to avoid chaining dependencies. So this is something that an earlier version of Lullabot's website did, and what our website used to be kind of a decoupled React site, and we would do this thing where we would make an API call and then execute JavaScript, and then based on the results of that API call, we would execute another one, and that would go on a couple times. And you can see these chains up there, and that's a chain of dependencies that takes a lot of time. And you can see in this particular case, it took maybe about a little over a second, maybe a half second, something like that. And that kind of adds up. And that's like really, really annoying, in my humble opinion. Looking at the performance tab is a great way to kind of see these requests come in and to see how they're chained together. So optimizations within the rendering step. So we were talking about the optimizations of the download steps, but let's talk about the optimization of the rendering step, right? So critical path. The critical path is anything that blocks your rendering, right? So their images are not in the critical path. Your CSS is in the critical path. JavaScript in the head is your critical path. Fonts are very, very important in order to display text. You want to kind of minimize anything that blocks rendering. You know, you want to get this data and get this website rendered as quickly as you can. And you also want to talk about when you're doing things like layouts and in animations, you want to minimize, when you're doing animations, you want to minimize layouts, and you want to minimize paints. So animations can cause repaints if you're using properties like background position, top left, bottom. Has anyone ever gone to like one of those like fancy parallax websites, right? And you start scrolling, and when it's scrolling, it's going like that, and it's like really annoying. That is usually the background position being animated, which triggers repaints. There are better ways to do it. You can skip straight to compositing by animating transforms and opacity. So like in the example that I mentioned about like animating the background position of the image, a better way to do that would be insert the image directly into the DOM and then use CSS transforms to move that up. And you can bind those transforms to the scroll position, so similar to what had been done with the background position. And at that point, the browser is smart enough where it will not trigger repaints. It will just trigger composite. And then you will see a silky smooth, still probably very annoying parallax animation. So CSS optimizations. So it used to be like good practice back in the day when people were trying to minimize network requests to insert their images into their CSS. And they would do that through a method called B64 encoding. So you would basically take your JPEG or GIF or whatever, and you would, convert that into text and insert that as a background image into your, as one of your CSS properties. And it would avoid that network request because the image would be embedded into the CSS. And I did a lot of this back in the day. It's kind of like not a great idea though. It makes the style sheets very large, which makes sense because you're putting in the image into a style sheet. It makes them a little bit harder to compress, as you have like text assets on the server. your server software will automatically like zip it up before it sends it to the browser, and then the browser will unzip it, and it'll do this all behind your back, so you don't even know what's going on. But it just, of course, will save bandwidth. And if you're embedding images in there, it makes it really, really inefficient to do that. But most importantly, it takes what was a non-critical asset and it makes it a critical asset. So you have this image, which is a non-critical asset, and all of a sudden you have it in CSS and it becomes a very critical asset. And so that's kind of an anti-pattern now. It's important to avoid your large style sheets. You want to use componentization as much as possible and only load the necessary CSS. So if I have, some type of media element, I would, in a perfect world, I'm going to create a CSS just for this little component, and I'm going to have some logic within my web app, and I'm going to say, if this component is on this page, ensure that the CSS is loaded. And a lot of modern content management systems and apps can do this out of the box. And they will also intelligently bundle those various different assets. It'll realize that, hey, these components are showing up on multiple pages together, so I'm going to bundle them into one big CSS bundle together, and that's kind of neat. There's a JavaScript library. I don't know if it's library or process. It's definitely a library called Critical, and it's made by Adi Asmani. And what it will do is it will look at it will evaluate your website, and it will look at your style sheets, and it will say, I'm going to grab only the styles that are being used. And when you do that, it's kind of very surprising that you might have, say, I don't know, a 500 kilobyte style sheet, and out of that, maybe 50-ish are being used, 50 kilobytes. So you have like all these styles that are being downloaded to the browser that the browser has to parse and interpret, and it's not being used. So you want to kind of split that up. There's a coverage tool that, if we have time, we'll go through that will actually show you that also. JavaScript is probably the most expensive. JavaScript is definitely the most expensive resource that you send to the browser. Your browser has to parse the JavaScript, it has to execute the JavaScript, and it has to do that based on various different criteria. And that takes a lot of time and effort, and it's not just about your phone, it's about like the slower phones and slower computers and things like that. You want to only load the appropriate amount of JavaScript, and there's a lot of ways to do that. Like you have like the concept of tree shaking in the JavaScript world, where it kind of looks at your bundle and it figures out what you're actually using, and then it repackages only the stuff that you're using, or you can do it manually. I was on a project one time, and we were able to reduce the bundle size by, I want to say, like close to a megabyte, and it was because the code syntax highlighting was being loaded everywhere, including on the home page where there was no code. And so you take that out, and everything goes down. JavaScript is a single thread application, or JavaScript is single threaded, and so you could have like, I have this cool picture here, and you could have like a million different cores, but only one of them is actually doing work. And there's an exception to this with web workers, but web workers API is a little bit weird and it doesn't have access to the DOM. In the typical situation, you have one CPU doing all the work, and so that can dramatically slow things down. In 2018, your average phone with your average website had, was it like almost 2 seconds of JavaScript processing in there. So that's like 2 seconds where people are just like waiting for this website to become active and getting very upset with it. At least I'm getting upset with it. Also, take note of how quick your latest iPhones are and your latest Google Pixels and things are compared to the average phones out there. The average phone is a lot slower than your phone, not knowing what phone you have, but it's something to keep in mind. Less JavaScript, the better, and you want to identify unused code through the Chrome Dev Tools, coverage tools, and you just want to identify like bad third-party scripts that like get in there and do things. I've also seen various websites load multiple versions of jQuery. They will have like a little talk widget, chat with us widget on the bottom right, and that will bring in its own version of jQuery where there might be a fully functioning version of jQuery just loaded through the regular site, and things like that can add a lot of time. As I said, like Webpack and modern JavaScript frameworks can do code splitting and tree shaking, and lots of cool things like that. And profiling JavaScript. So, all right. So profiling JavaScript, we're gonna see if I can do this. So I have this cool website, and I don't know if this is gonna show. It probably will. So hold on. It's a website that I worked with my daughter when I was learning the ES6 variant of JavaScript, and it's pretty cool. You can go to this right now if you want. It's sillysounds.herschel.com. And we did things like this. It's pretty cool. So, and so the code is up on GitHub, and it's all just like kind of vanilla JavaScript, and you can kind of look at it. And the thing is, I like bringing this up in presentations because all my functions are like not anonymous functions. They're named, and it's really easy to debug. And so we're gonna look at this. We're going to profile some things, right? So I'm going to go to the Performance tab. I'm going to clear everything out. I'm going to hit the recording button. So when you hit the record button, it doesn't reload the page. If I were to hit this refresh and start profiling, it would reload the page. But I can hit buttons here. Let me get back over here. And we can hit stop. Now, there's not gonna be a heck of a lot going on here, but we can kind of get an idea of what's happening here by selecting this and kind of looking at the rendering, scripting, and painting. This is really quick because it's a very, very small app, but you can kind of get an idea. You can look at these events that are being triggered here, and in certain cases, it'll actually tell you exactly where it is. So I can look at this right here and I can say, hey, this is being triggered right here, and I go back to my performance tab across the top and I can say, well, this is 7 milliseconds. In certain cases, it's going to be 700 milliseconds or like long threads and things like that. And it'll give you an idea of like where to look and where to focus your kind of input. So we can maybe look around over here, and you're going to see, of course, a lot of similar things because all I was doing was just hitting keys, but it'll give you an idea. When you're doing full-on, another website I like to pick on is usatoday.com because it has like 1 million bytes of JavaScript in it. Is this coming in? That's not where I was looking. All right, so that's reloading and it's profiling. There's the rain. So this is going to take a pretty long time. I'm eventually going to stop it. But what I'm going to look at here is we're going to look at third-party scripts also, which is kind of fun. So let's just stop this right here. And we're going to wait for it to load. You see this video in the background? And you can see a lot of yellow. The yellow is JavaScript main thread execution. The little red ticks at the top are like where the frame rates are lowering down because your computer can't keep up. Purple is going to be layout, and green is what is green? Green is painting. So let's kind of look at some of this stuff. So the first thing is you're going to see that we have like 23 seconds of scripting here. Like that's a very long time. Like that's a slow website. A half a second of painting, and 2.3 seconds of rendering. That's completely not horrible. It's not completely out of bounds, but it sounds kind of a lot. Like these late rendering operations are probably ads coming in. So you can maybe select some of this stuff, and we can maybe look at the main thread here. I'm going to scroll down over here. And you can kind of get an idea of what's happening here. So we have like this require.js, of course, is pulling in other files. And you can maybe get an idea of what it's pulling in by looking at the bottom of this flame chart here. We can maybe even look over here. It's going to do a network request, and it's going to start pulling in other stuff. It'll take you right, if you click on it, it'll take you right to the functions that are doing things. This is minified or uglified. I don't quite know what it's doing. But so in this case, we have 30 seconds of JavaScript execution in a slow website. And we know a lot of it is third-party scripts, but we don't know how much of it is third-party scripts. We're going to go to the bottom-up tab right here. And by default, your bottom-up tag, or your bottom-up is going to have like no grouping. And you can kind of see like what's happening here. This kind of seems like a little bit out for me. So normally, like this should be kind of changing as it happens. Like as I expand and contract this, you'll normally see this changing. I'm kind of wondering why it's not. I might try a different website. So something that I've noticed is Google Chrome updates itself a heck of a lot. It's updated itself like while I've been in presentations before. Oh, this is great. So I'm going to pick on like maybe I'm going to go back to TechCrunch. Let's do a quick review of this. How am I on time? What's that? The stream is stopped? Uh-oh. Should I wrap it up? Oh, okay. So I'm going to keep this up. Like, I'm approaching the end. So let me show this third-party script thing right here, and then we will continue to go. So normally, you should be able to zoom in here, and you see how things are kind of moving around. On the bottom, we have everything zoomed. So that's what I initially expected to happen. So I selected the option. You can select the option down here to group by subdomain or group by product. And when you do this, it'll actually tell you down here what product is using up a lot of time. So you can see like this ad tech, whatever this is using almost 2 seconds. You have motads using 1.2 seconds. And then you have the long tail down here. And you can also group by subdomain. So at this point, I am going to move on. I'm going to skip the web page test stuff. And I'm going to go to my key takeaways. So learn how to profile stuff. Profiling stuff is like super important. You can't fix your problem unless you can identify your problem. Practice measuring things. I constantly go to websites and I'm like, how did you do this? How did you look at this? Less JavaScript, the better. And resource hints are awesome. You know, like resource hints are something that you can start using today. And I'm a big believer in like the open web. You know, you hear these horror stories of like, you know, Google and Apple kind of acting as like the gatekeepers, you know, with their arbitrary policies into app stores and things like that can just, you know, take things down. And I believe in an open web and just letting everybody do it. And you need to make the open web like really good in order to compete with native apps. And yeah, that's it for me.